So in this lesson, we're going to be talking about data collection, and we're also going to be talking about what's random and what's not random. So let's first go ahead and talk about some vocabulary. So when we're talking about a population, what we mean is the entire group from whom you are collecting data. So that means everybody. So if we were talking about, we wanted to look at data on the alphabet, then our population would be the 26 letters of the alphabet of the English language. A population statistic is data that you actually collect about your entire population. But when we talk about a sample is a subset of the population. So for example, going back to that alphabet one, if we were talking about a sample of it, we may go ahead and ask, okay, well, what's 5 letters from the alphabet? And we may talk about the first 5 letters, A, B, C, D, E. That would be a subset of the population. It's usually representative of the population, and I would say this is kind of representative because it has those vowels that we speak about when we're talking about letters, and it has some of the consonants. But if I only talked about A, E, I, O, and U, it may not be representative of the population because it would not contain the consonants. Okay, a sample statistic is data that you collect just from the sample set. Now, surveys don't always have to be like, hey, what do you think about this? Okay, a survey is actually just a method of collecting data from a representative sample of a population. So when people talk about surveying, they don't necessarily mean that they're asking people questions. It just means that they've gone ahead and looked at a specific group, not everybody. Okay, and finally, random sampling. Random sampling is a method that we use for collecting data, and it allows us to get information that hopefully is informative about everybody, but it doesn't have to make us figure out what everybody actually has done. So it's a methodical use of selection that allows for all members of a population to have an equal chance of being selected. So for example, if we wanted to figure out, what do people in the entire world think about climate change? Well, there's over 7 billion people in the world. We're not going to be able to get information from every single person in the world. Some of them can't even communicate right now because they're newborns. So we would have to do some random sampling from people in different countries. So now let's go ahead and talk about some examples of populations and how we would go ahead and sample them. When we're talking about sampling, we mean, do we need to go ahead and do a sample survey, or do we go ahead and can we sample the entire population? So when you are doing some type of project, you usually have a driving question. So same thing as when you're trying to get information about a group of people. When you're trying to get information about a group of people, you need to have a driving question. What information do you really want? So this year, we're supposed to be having a presidential election. And so we might want to know, well, which candidate is most likely to win the presidential election before the actual election takes place? So who is our population? Well, when you're thinking about that, there's a difference between someone who's 5 years old versus someone who's 18 or over the age of 18. So if you're 5 years old, what can you not do in terms of a presidential election? Well, you can't vote. If you're over 18, you might be able to vote. And so we definitely can't do the whole entire United States. But we could do, our population might be people over 18. But if we look at people over 18, can everybody who's over 18 vote? Well, yes and no. You can because you have the right. However, they may not be what we call registered. So our population is who we can go ahead and get this information from. And so our population would be people who are registered to vote because They are the ones that can vote. But how are we going to get that information? Should we get our information from everybody who's registered to vote? Would that be feasible? No. So we would want to get our information for this, because it's not the final vote, as a sample. We would want to sample it from groups of voters from each state, probably. Or we may want to go ahead and look at it as representative groups from each state. Maybe we want to make sure that we get people from each party in that. So there might be other ways that we can go ahead and get some sample information. Okay, so maybe this is your driving question for your survey. Maybe more dear to your heart. What are students' favorite meals served by the cafeteria? So who's your population? Should it be me as your teacher? Should I be involved in this? No, it should just be students, and it shouldn't be students that don't go to your school. It should be students at your school, right? So not just students, it should be students at your school. Okay, now, how will you get this information? Is it feasible to get everybody's opinion? Well, depends on the size of your school. If your school is pretty small, it might be something that you can do. But what if the people never, ever eat cafeteria food? Would you want their opinion? So, is there a difference of opinion if you go to a school where there's 6th through 12th graders? Maybe 6th graders like different things than the 11th and 12th graders. So you might want to go ahead and, for example, get a sample of students from each grade level. You may want to only have samples from people who actually eat the cafeteria food at least a certain number of times per week. Okay, what if this was your driving question? Right now, we're experiencing an outbreak of coronavirus, and it's called a pandemic. So maybe you're an epidemiologist and you're trying to figure out what age group is least likely to get sick from the coronavirus. So who's the population? Remember, the population is the group of people you're studying. Well, it would be everyone in the world right now, because this is a pandemic. Now, who's the sample that you're going to get this data from? Well, the sample would be the groups of people of all ages with all types of health conditions, because they say that people who are more likely to get sick seem to have some condition that makes them more likely to have adverse effects. So you need people who are healthy and got sick. You need some people who are not so healthy and maybe got sick. So you need them to be old, you need them to be young, and you need them to have already been healthy before they got sick, and some who were already a little bit sick before they got coronavirus. Okay, so what do 7th graders want to do for Spirit Week? So how would you collect the data? Well, maybe you could do a survey. And again, depends on what size school you go to. So if you go to a small school, you could survey every student. But if you only went to a very large school where you have more than, let's say, 500 students in the 7th grade, you may want to go ahead and survey random students. And you want to limit it to students in which grade? Okay, 7th grade. So is this data a population or a sample statistic? Well, if you survey all the students in 7th grade, like we could do when we only have, 50-something students in our 7th grade. So we could go ahead and do that. And for us, this would be a population statistic. Why? Because we are including all 7th graders. Okay, so if we want to know what is the average grade on the semester exam for Mrs. Johnson's class, okay, or any teacher, how would we collect the data? Well, we need to know all of the grades. So we would average all grades from the exam. So when we say all, that means it's a population. Okay, why? Because it's all the exam grades. Okay, what is the most efficient method of evacuating a school building? Well, we would go ahead and we would probably try and time methods of evacuating. Okay, now, is this going to be a population or is it going to be a sample? Well, actually, this would be a sample because it's not possible for us to do every single method of evacuating a school building because there's no way for us to time how long it would take for us to. If the first floor was blocked, how would we get people off of the second floor and do things like that? So it would be a sample. Okay, and the reason is because we are going to only be using some methods. Not all. Okay, how many students in your school ride the bus home? Okay, again, this would depend on the size of your school. So let's pretend we go to a very, very, very large school where there's like over 2,000 students in the school. And you want to know how many students ride the bus home. Okay, so we may want to go ahead and, again, do a survey of students from different grade levels. Okay, so this would have to be a sample statistic, and that's because we cannot get info on from every student. Okay, so now we're going to go ahead and we're going to look at, is it random or is it not random? Okay, so in order for something to be random, who or what is selected is not known ahead of time by at least one entity. So you have the person who is doing the selection, we'll call them the expert. And then we'll go ahead and say this person is, or the test subject. So either the expert knows ahead of time who is going to be tested, or the person who's being tested knows ahead of time that they're going to be tested, but the expert doesn't. So sometimes neither of them may know, and that's something that you learn later. Okay, so is it random? A school gets 20 free tickets to a screening of a movie for students and announces that students may stop by the office to pick one up until they are gone. So are they giving the tickets away in a random way? No, not random. Okay, and the reason it's not random is because anybody has an equal chance of getting there. They're just going to hand it out to whoever comes. There's no limit to, the groups of people that come in and get the tickets. Okay, so it's not a random way of giving it to them at all. There's no structure to it. Okay, so, this one. A store gives away every fifth person in the store a coupon for 50% off any item. Would this be random? Yes, this is definitely going to be random. And that's because the store doesn't have any control usually about who that fifth person is going to be. And unless they have made an announcement that every fifth person is going to be getting a 50% off coupon, which I don't think they would have done, then that fifth person is going to be lined up randomly in the queue to come into the store. Okay, so in case you didn't know, an epidemiologist is a person who basically looks at the statistics and numbers that occur with disease and public health issues. Okay, so if an epidemiologist is trying to determine if children between 10 and 19 are less likely to get infected by the coronavirus or just do not show symptoms. So that's their question that they're trying to learn. So they ask the hospitals to let them know when a patient in that age group is admitted to their hospital. So would this be random or not random? Well, the reason that this would fall in the category of not random is because their question is that if you are less likely to get infected by the coronavirus or just do not show symptoms. But in order to get admitted to the hospital, you have to have some symptoms. So therefore, everybody who's going into the hospital has to have some symptoms. Therefore, this would not be random. A teacher asks students to answer a question and then chooses the person from the name bucket on her desk. Random or not random? This would be random because she's not picking it just because they raised their hand or they were the first person, but she's choosing them from the name bucket. Okay, now what do we do with random samples? Okay, so random samples we can go ahead and we can use to get information. Okay, so at the end of the school year, a sample survey was conducted about rising 8th graders' preference for their elective course. And so we are going to answer some questions about this. So let's first figure out how many people participated in our survey. So 38 said they prefer PE, 14 said they prefer music, and 28 prefer art. So if we go ahead and we add those together, we get 80 participants. So at this particular school, they expect to have 500 8th graders the next school year. So out of those 500, how many of them would be expected to want PE as their first choice? So this is a ratio, and we can solve this with proportions. So first we look at our survey. In our survey, we said 38 out of 80 prefer PE. Now, next year, we're expecting 500 students, and we want to know how many of them want PE. So now we're going to go ahead and solve. So to solve our proportion, we cross multiply. So we have 80 times P and 500 times 38, which gives me 19,000. And now I divide both sides by 80. And I get that I have about 237 and 5/10, and these are people, so I would expect that it's about 238 8th graders prefer PE as their first choice. Okay, so now let's move to the second one. So if we were looking at the same data and we were asking, well, what percent of students do not prefer PE? So we're not looking at a specific number, we're looking now at a percent. And it also says, do not prefer PE. Well, who are the people in the survey that didn't prefer PE? It was the ones that chose art and the ones that chose music. So if I go ahead and add those two together, 28 plus 14 is going to give me 42. So 42 out of 80 did not prefer PE. And this time we're looking for a percent, and a percent is always out of 100. So now I can go ahead and I can solve. 80 times P, 100 times 42, which is 4,200. And now I go ahead and I do 4,200 and 80, both divided by 80. And so my percentage is about, so my percentage is 52 and 5/10%. okay, of the students do not prefer PE. So of those 500 students that are expected in 8th grade the following year, how many would not be expected to prefer art? Well, not taking art means that they prefer which electives? That means they're expected to want to take PE or music. So PE and music added together would make 52. So 52 out of every 80 students in the 8th grade next year would prefer or would not prefer art. So now we can go ahead and figure out how many of that there is. So again, solving our proportion, we have 80 times P, 500 times 52. And as we finish our solution, we get that exactly 325 students would be our expectation of students not preferring art.